Something just outran the stars over Mars. In October 2025, a camera on the Perseverance rover captured a flash moving at a blistering 60 kilometers per second. This was no meteor. It perfectly matched the speed and timing of Interstellar Visitor 3, I-Atlas, during its historic flyby. Then, the Mars orbiters tasked with watching it went dark. The raw images vanished. Unconfirmed reports of multiple objects and a strange, inexplicable green glow set the scientific world on edge. Let's explore this together. The 60-kilometer streak. How do you spot a ghost in the machine? In early October 2025, the global astronomy community was electrified by a time-lapse posted from Perseverance's public image archive. It showed a single razor-thin streak cutting across the Martian starscape. The calculated velocity was an astonishing 60 kilometers per second, double Earth's own orbital speed of 30 kilometers per second. That's far faster than any local satellite or meteor. To put that in perspective, NASA's Parker Solar Probe, the fastest object humans have ever built, only hits its top speed deep in the sun's gravity well. This object was maintaining that velocity out at Mars. The methodology was sound. The streak's motion was measured frame by frame against background stars, ruling out a simple camera artifact or cosmic ray. This process echoed the legacy of observers like Gennady Borisov, the amateur who discovered the second interstellar comet, 2I Borisov, in 2019 from his own backyard observatory, proving that monumental discoveries can come from anywhere. The calculation was undeniable. If the 60 kilometers per second speed was correct, the track matched the predicted path of 3I Atlas almost perfectly. The discovery was out, but the burden of proof had just begun. Crowdsourced chaos. What happens when a mystery goes viral? As soon as the Perseverance time-lapse hit the internet, forums and social media exploded. Hundreds of independent analysts downloaded the raw frames, running their own scripts to either confirm the streak or debunk it. The debate instantly fractured. Some groups not only reproduced the main track, but also claimed to find hints of secondary, faster-moving objects in the data from the following day. Others, using different noise reduction pipelines, saw nothing but static. Then, at 3 minutes past midnight UTC, one team's stacked animation showed a brief, anomalous green flash, centered at a wavelength near 510 nanometers. Speculation ignited. Was this a genuine emission from the object, or just a cosmic ray strike amplified by aggressive image processing? Rival teams argued over color calibration and the signal-to-noise ratio, which was barely above the detection threshold. This is the modern face of discovery. Championed by figures like Dr. Chris Lintott of the Zooniverse Project, where millions of citizen scientists help process raw data from telescopes. But without a clear institutional signal to validate the findings, this crowdsourced effort was descending into pure chaos. Mars's front row seat. Why was Mars the perfect place to watch this interstellar show? For a brief window in early October, Mars and its fleet of orbiters had the best view in the solar system. 3 key spacecraft were tasked with observing 3I Atlas as it passed 9 million kilometers away. NASA's Mars Reconnaissance Orbiter with its powerful high-rise camera, the European Space Agency's Trace Gas Orbiter, and the veteran Mars Express. Let me explain the challenge here. At that vast distance, even high-rise, a camera with a resolution of 30 centimeters per pixel on the Martian surface would see the object as a smudge just a few pixels wide, with a best-case resolution of nearly 50 kilometers per pixel. The team, led by planetary scientist Dr. Alfred McEwen, had to reprogram the orbiter, which completes a full orbit every 112 minutes, to aim at a tiny, fast-moving target against the blackness of deep space. Each snapshot was a calculated gamble with exposure, times carefully balanced to avoid saturation or motion blur. Aim too early and you get empty space. Aim too late, and the object has already vanished from the frame. It was a race against geometry and time, and these orbiters were our only eyes. If 3I Atlas did anything unusual, like fragmenting or firing off jets, these images would be the only proof. The silent archives. Where did the data go? In the days following the flyby, an unnerving silence fell over the public data archives. Normally, images from major events like this, especially from Mars orbiters, appear within a few days in their raw, uncalibrated form. This time, there was nothing. No files from HiRISE, no quick-look frames from Mars Express. The silence from official channels was absolute. Inside the Jet Propulsion Laboratory, the imaging teams were facing immense pressure. The delay wasn't just bureaucracy. Processing data from a faint object moving at 60 kilometers per second is, honestly, a nightmare. Standard software pipelines, designed for static Martian landscapes, just break down completely. As Dr. Rita Beebe, a pioneer of NASA's planetary data system, could attest, cleaning and validating this kind of data for public release is a painstaking process that can take weeks. Releasing images with uncorrected geometric distortion or without proper flat fielding could create artifacts that look like real objects. The data downlink rate from Mars, often limited to less than 2 megabits per second, created a huge bottleneck for the gigabytes of raw data. Wait too long and you fuel accusations of a cover-up. Every pixel had to be perfect. Green without dicarbon. Can you have fire without smoke? In cometary science, a green glow is usually an open and shut case. It's the signature of dicarbon, or C2, a simple molecule that glows bright green when sunlight breaks it apart, creating telltale spectral features called swan bands, especially the bright one at 516.5 nanometers. It's so reliable that astronomers call it a comet's chemical calling card. This is where the story of 3I Atlas gets strange. The unconfirmed green flash reported in the Perseverance frames implied dicarbon was present, but the first trickle of provisional spectral data from the Mars orbiters hinted at the exact opposite. The emission bands where dicarbon should have been were weak or missing entirely from the spectrum. In a laboratory, a green glow without dicarbon is a flat-out contradiction. Veteran comet expert Dr. Michael Mumma of NASA has spent his career analyzing these chemical fingerprints, and standard physics has no easy explanation for this. It would require a completely new chemical pathway, perhaps involving other ionized elements to produce that color. The question became a battleground. Was the green flash a real, physics-defying event, or just a ghost in the data? Without the final, calibrated spectra, the paradox remained unsolved. Chemistry that defies models. What if this visitor isn't playing by our rules? The spectral data that eventually emerged from the Mars campaign was a direct challenge to textbook comet science. First, reports from the Mars Express team highlighted a chemical fingerprint dominated by nickel, not iron, at a ratio never before seen. In all known solar system comets, which are largely composed of water ice and iron-rich silicates, iron is far more abundant. Here, the nickel signature towered over everything else. Then, the trace gas orbiter found that the object was spewing out vast amounts of carbon dioxide, with a CO2 to water vapor ratio exceeding 10:1. For a comet, water should be the dominant gas. This chemistry was already strange, but the images revealed something even weirder. The object had a plume, a jet of material, blasting forward toward the sun. This defies normal cometary behavior. This anti-sunward jet was sharp and well-defined, not the broad, fan-shaped tail we expect. As Dr. Karen Meach, who led the study of our first interstellar visitor Oumuamua, knows well, these objects can shatter our expectations. The data implied 3I Atlas was incredibly dense, with a calculated mass of at least 10 billion tons, more like an asteroid than a fluffy comet. Each new piece of data made natural explanations harder and harder to justify. The WOW signal coincident. Could a 72-second radio anomaly from 1977 be linked to this? Harvard astrophysicist Dr. Avi Loeb, known for pushing the boundaries of interstellar research, entered the debate with, a pretty provocative calculation. His team traced the path of 3/Atlas backward in time and found that its trajectory through space overlapped with the location of the famous 1977 WOW signal. Detected by the Big Ear Radio Telescope in Ohio, the WOW signal was a powerful 72-second radio burst at 1,420.4 MHz, the precise frequency of neutral hydrogen. It's long been considered the most promising candidate for an artificial, extraterrestrial signal, precisely because nature doesn't typically broadcast on such a narrow, specific channel. Loeb's team calculated the odds of a random interstellar object passing through those exact coordinates as just 0.6%. That's rare, but not impossible. Skeptics in the SETI community urged caution, pointing out the risks of finding patterns after the fact. Still, the tantalizing connection, championed by a figure behind initiatives like the Galileo project, made the object a prime target for radio follow-up. 5 weeks in solar shadow. Just as the mystery peaked, the object vanished. After October 29th, 3I Atlas slipped behind the sun, entering a communication blackout zone. This is a normal part of orbital mechanics called solar conjunction, where the sun's glare makes observation from both Earth and Mars impossible. For 5 long weeks, every telescope was blind. Scientists, amateurs, and SETI researchers could only watch the calendar and wait for early December 2025, when the object was predicted to re-emerge into the pre-dawn sky. Experts in orbital mechanics like JPL's Dr. David Farnokia, whose ephemeris data is the lifeline for these campaigns, had provided the precise calculations, but everything depended on what the object did while it was out of sight. 4 key questions hung in the air. Would its brightness have changed, indicating fragmentation? Would its trajectory have shifted, hinting at outgassing or even maneuvering? Would its strange sunward jet still be there? This brief observational window in December would be decisive. Everyone was waiting to see what would emerge from that solar shadow. The evidence ladder. How do we separate a real signal from wishful thinking? In a situation this chaotic, scientists rely on a ladder of evidence. At the very bottom rung is repeatability. A genuine streak or flash must appear in independent analyses from different teams using different software, all matching the same time and location. The next rung up is multi-band confirmation. A real physical object should show up in different color filters and wavelengths, from infrared to ultraviolet, not just flicker in a single visible light channel. Above that, you have geometric and dynamic proof. If there are multiple objects, they must move in parallel, following predictable orbits. They can't just jump around randomly as data is processed. The highest and most difficult rung is evidence of artificiality, what is sometimes called the Sagan standard. As the great science communicator Dr. Carl Sagan famously said, "Extraordinary claims require extraordinary evidence." This would be something nature simply cannot do. Deliberate maneuvers, repeating geometric patterns, or a narrowband radio signal. Every anomaly associated with 3I Atlas had to climb this ladder, and the burden of proof grew heavier with every step. An unresolved puzzle. So, where does this leave us? The facts on the table are a stack of powerful anomalies. 3I Atlas showed a chemical makeup that challenges our models of comets, with its strange nickel-to-iron ratio and a 10-to-1 dominance of carbon dioxide over water. It displayed a massive anti-sunward plume that defies our understanding of cometary dynamics, and its trajectory carries a statistically rare, though unproven link to the 1977 WOW signal. Yet the most critical evidence, the high-resolution images and complete spectral data from the Mars Flyby, remains closely held by the world's space agencies as it undergoes rigorous calibration. As the object heads toward its perihelion, its closest approach to the Sun, the forces acting upon it will be at their peak. Dr. Jill Tarter, a pioneer at the SETI Institute, has spent a career reminding us that this work requires patience and rigorous skepticism. For now, 3I Atlas remains an interstellar puzzle. We have a compelling collection of clues, but no confirmed answers. The only thing certain is that the mystery demands we keep watching. The universe rarely gives up its secrets easily. The story of 3I Atlas is a perfect example of how one object can challenge everything we think we know about our place in the cosmos. Is it a new class of comet, a natural phenomenon we've never seen before, or something else entirely? Only more data and more scrutiny will tell. What are your thoughts on this interstellar mystery? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the biggest questions in space. Thanks for watching Future Facts.